Here is our third practice problem for grade 11 physics under the section Newton's law of universal gravitation. Now, this question comes from a question 4 from a past paper that says the Earth and Mars are positioned in the universe such that they are 2.25 times 10 to the power 8 meters apart. Now, we can see that that's given to us. The radius of the Earth is 6.37 times 10 to the power 6 meters. So if we fill this in on the diagram, the radius of the Earth would be from the center to the surface. That is going to be RE. If the radius and mass of Mars is 3.39 times 10 to the power 6 meters and 6.39 times 10 to the power 23 kgs respectively. Now, you guys, something that you must understand, which they absolutely love doing in physics, is giving you consecutive bits of information and at the end saying respectively. What does that mean? We need to understand that when they say respectively, they mean in that order. They are first mentioning radius and mass, and then they're giving you two values. So obviously, because they mentioned radius first, the first value is for radius, and the second value is for mass. Okay, so let's just fill this in. From the center of Mars to its surface, that is going to be the radius of Mars. Now, if we look underneath these planets, we are given their masses as well. And here's the thing. Because we are given information for the Earth in this question, there's no need for you to refer to your formula sheet. If the question gives you specific values within the question for the Earth, please use the values that they give you. If there are no values for the Earth given, then only refer to your formula sheet. Okay, now that we have everything in front of us, let's look at 4.1. State Newton's universal law of gravitation. So we've stated this in two other past paper questions, basically the two previous videos. So the two videos prior to this. And I'm not going to write it down right now, but I'm just going to mention it. We know that Newton's universal law of gravitation states that every body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Or we can say the square of the distance between their centers. 4.2 says, calculate the force that Mars exerts on Earth. So the force that Mars exerts on Earth. Since they require us to calculate force, the formula that we're going to use is F is equal to G m1 m2 over r squared. Remember that G is 6.67 times 10 to the minus 11. I will take m1 as the mass of the Earth. It is given as 6.0 times 10 to the power 24. I'll take m2 as the mass of Mars, which is given as 6.39 times 10 to the power 23. Now, what about the distances between them? Remember that these are planetary bodies. They are spherical. So when we take the distances between them, it has to be the distances between their centers, which means that we have to take the radius of the Earth, add on 2.25 times 10 to the power 8, and then add on the radius of Mars, because that is the total distance from the center of the Earth to the center of Mars. Okay. Radius of the Earth was given as 6.37 times 10 to the power 6. Onto that, I am adding that distance between the two planets, 2.25 times 10 to the power 8. Onto that, I am adding the radius of Mars, which was given as 3.39 times 10 to the power 6. Don't forget to square. So you guys, because it is a lot to put onto your calculator, just make sure that you are double checking the values as you put them on to avoid wasting time if you have to recalculate. Now, once you plug this in to your calculator, you should get 4.64 times 10 to the power 21 newtons. So that is the force that the Earth exerts on Mars. Question 4.3 says, is the force calculated in 4.2 a contact or non-contact force? Obviously, this is a non-contact force. The planets are not touching each other. So they are just exerting forces of attraction. So 4.3 is a non-contact force. Let's go on to 4.4. 4.4 says calculate the acceleration due to gravity on Mars. Now, there are only two formulas in the section. And one is if you're calculating electrostatic force, which is a formula that we've been using all along. And the other is if you are calculating the acceleration due to gravity. That is G is equal to gm over r squared. And this particular formula is used to calculate gravity on different planets. Rather, the acceleration due to gravity on different planets. So we work specifically with the planet itself. Now we are asked to calculate acceleration due to gravity on Mars, which means that where we have m in the formula, we will specifically use the mass of Mars, and where we have r, we will specifically use the radius of Mars. Now just remember, these values have been provided to you, so all you have to do is substitute into your formula. Mass of Mars was given as 6.39 times 10 to the power, it was actually 23. Radius of Mars was given as 3.39 times 10 to the power 6. Don't forget to square. Now you're just going to put that onto your calculator and you should get 3.71. And please remember that this formula represents acceleration due to gravity. So your unit is going to be meters per second squared. Which is actually a lot less compared to Earth. Remember, gravity on Earth is 9.8 meters per second squared. But on Mars, it's only 3.71. Okay, let's go on to 4.5. It says, what will be the force that the Earth exerts on Mars? Now you guys notice in 4.2, you calculated the force that Mars exerts on the Earth. So the force that the Earth exerts on Mars should be exactly the same. And why they should be exactly the same is due to Newton's third law. These planets will exert the exact same force on each other. So it's the same value that we had in 4.2.